Hey guys, what's up? Kelvin here. Today we're going to be taking a very quick look at traditional, regular, plain, whatever else you'd like to call it, MPLS Layer 3 VPN. So without further ado, I hope to see you right after this intro. Now, you might be asking the question, why are we talking about traditional MPLS Layer 3 VPNs when we're doing a series that's called Unified MPLS? And the reason we're doing so is because the fundamental MPLS forwarding operations carry forward to Unified MPLS. So it's very important that you can take the MPLS forwarding operations that would come along with like a basic or regular Layer 3 VPN and bring that to your understanding of Unified MPLS. So if you can do that, then you'll have a much easier time understanding and implementing Unified MPLS. It's all the same applesauce because the thing is that if you think about the term Unified MPLS, inside that term you have the term MPLS, which means that the base of it is MPLS. All you're doing is you're just unifying a bunch of other features in order to form a more scalable architecture. So you can see here on this diagram that we've got a basic elementary layered VPN. So this really is something special. We've got like a single customer with two customer edges, and we've got two provider edges and a bunch of provider routers here in the core. And a couple things I'd like to point your attention to just very quickly though. Firstly, you can see here that all the provider routers, so your provider and provider edge routers, are all in this one IGP domain, this OSPF1 domain. Something else that you can see that I have boxed off in the orange square here is that we're using IGP+LDP in order to build our dynamic MPLS label switch paths, or LSPs. So these LSPs we need in order to be able to send label packets over a given path, and half the routers not just completely freak out at the sight of these labels. They're like, what are we going to do with these labels? We have not been told what to do with these labels at all. We don't know where to send packets that are labeled with these MPLS labels. So that's what we're doing when we're building these MPLS label switch paths. We're telling the routers in the MPLS core about how to react to a given label and how to forward them. So we could build these MPLS LSPs statically, which will require MPLS static label bindings bidirectionally on all of the MPLS enabled routers. We could do something like RSVP traffic engineering in order to build signal traffic engineer tunnels for our labels of traps. But for our purposes here, like I said, this is just a very elementary L3 VPN, so IGP+LDP will be enough in order to get our topology information over and then build our label bindings and our dynamic LSP. We don't need anything fancy like MPLS traffic engineering. So lastly, you can also see that we're using eBGP as our CEPE routing protocol, though in this given context, it doesn't matter. You could even use something like RIP for your CEPE routing protocol if you were a masochist and you hated yourself. My point is that in this given context, it doesn't matter. So if you so desire, run whatever is to your heart's content. We're also running BGP VPNv4 here between our provider edges so that we can transport our VPN labeled routes and things like that. It is important to note that if we had multiple provider edges here, we would have a route reflector somewhere here because these are IBGP peers, intended to be IBGP peers anyway, which means that we have our full mesh requirement and things like split horizon, which means that we can't advertise IBGP route by default from one IBGP peer to another. So if we had multiple PEs here, multiple IBGP VPNv4 peers, we would have to configure a route reflector. But in this given topology, we only have two provider edges, so that works. It's just a noteworthy example to highlight in terms of needing IBGP route reflectors when you're doing VPNv4 over IBGP. Now, because we're using IGP+LDP, we need two components. We need IGP and, you guessed it, LDP. The reason that we need both is that in order to build our dynamic label switch paths, we need to do these two fundamentally important tasks. So firstly, we need to understand what the topology looks like. So we need to advertise our IP topology information. So, things like links and all that stuff. And we would do that with our routing protocol, with our interior gateway routing protocols. So we can't carve out our labeled paths if we don't know what the actual paths that we're trying to carve out look like in the first place. So that's what we're using our IGP for. So things like OSPF and ISIS are there in order to just push our regular IP routing information for, again, like our physical transports or loopback interfaces that we're using in order to do our BGP VPNv4 peerings, as an example. The second thing is that we need to actually send our labels. So in order to build a label switch path, we need the routers in between to actually know what the labels that they need to do something with are, firstly, and we need to tell the routers what that something that they're supposed to do actually is, whether it's forwarded out of this interface or whatever. And that's what we're using the label distribution protocol, or LDP, for. So the routers will basically take the topology information that the IGP that is configured has compiled for us, and then build label bindings for the prefixes advertised in the IHP given as dev requirements, and then form LTP neighborships between routers that are applicable in order to share those label bindings and build our fully label switch path. Now, with IGP and plus LDP, assuming that's all one domain, which in this case it is, right? We have one IGP domain here, which happens to be OSPF. Assuming that we have this one IGP domain and it's working properly, that's fine. We can, in ideal conditions, build an end-to-end transfer LSP with no problems. Because our VPN labels and our underlying VPN label switch path is all built with our BGP VPNv4 relationships that's going between the two applicable PEs, right? And these VPN labels help to direct traffic into the correct VRF. Now, that's the important part about this L3VPN review. So it's all about realizing that because this is all under one IGP domain, that's what makes it relatively easy. The fact that we have all this shared topology information within the IGP domain, and because this topology information is shared within the IGP domain, we have a relatively easy time getting LDP to generate these label bindings so we can build our LSP dynamically. Now, when we get into Unified MPLS, what you'll find is that this isn't necessarily the case, because you'll see that we have some added complexity in order to bridge the discontiguous IGP and LDP domains that we need in order to get our scalability where we want it. So with that said, like I said in the beginning, this is not an MPLS training substitute. So if you're not familiar with MPLS as much as you'd like to be in order to proceed with this Unified MPLS series, I strongly recommend that you look at some other course of training, like a video course or a book. So something like Luke DeGuine's Cisco Press MPLS Fundamentals book from however many years ago is a really good book for MPLS fundamentals. You can look at something like that in order to learn more about MPLS, forwarding operations and fundamentals and all of that before you learn about a special architecture to implement scalable MPLS transfer services, which is something that I hope makes sense. So that being said, that's going to be it for this basic MPLS L3 VPN review. I hope this helped you grasp any elements of basic L3 VPN that you may have needed before I got into the weeds in terms of the unified MPLS architecture, where all of this that I've talked about in this video will be presumed prerequisite knowledge. So if you liked this video and enjoyed it, please leave a like below, please subscribe and turn on notifications and do all that other fun stuff if you feel so inclined to. I'm hoping to post more videos soon. If you have any questions, concerns, feedback, or just want to strike up a conversation, please feel free to leave a comment below. All right, all. Thanks again. I hope to see you next time. See you next video.